So the way I have this course organized for each one, again, I told you study zone, assignments and quizzes. Usually you'll have a lecture presentation, a chapter outline, links to the e-text, videos you can watch, okay? We usually have a couple different kinds. Some are my videos, some are videos that I found that I think are helpful. So you can watch those. Also, sometimes we'll put quizzes and, or, you know, basically different activities that you can do to practice, all right? So we are going to go over the lecture presentation. All right, so and I'm gonna pull this over, see if I can, so I can close this part. All right. All right. See if I can pull this one. All right, perfect. All right, so anatomy. So what is it? It's the study of the structure and shape of the body, right? And the different parts of the body. And like I said, you can always print these out and bring them so you don't have to write down everything, okay? They're already posted in Canvas. Use observation to see sizes and relationships of different parts. All right, gross anatomy. So gross has to do, it's not like something is nasty. Gross means large, okay? So you're dealing with large structures that you can easily see. All right, so the human body, we'll look at examples of gross anatomy using the digestive system as an example. All right. So these are structures you would not need a microscope to see, okay? If you were to have a cadaver, which we have a synthetic cadaver, which you'll get the chance to see in lab, you'd be able to see a lot of these structures, okay? So you can see the mouth and the tongue, pharynx, liver, gallbladder, stomach, pancreas, small intestine, large intestine, right? So those are all part of gross anatomy. Microscopic anatomy, on the other hand, means you can't see them just with your eyes. You got to use a microscope, right? And like I said, try to summarize. Try not to write every single word that's on the page, because I want you really paying attention, not just trying to catch it, every single word. All right, so you can see the stomach with your eye, but to see what's going on a more microscopic level, if you use a microscope, you can see these gastric pits, the epithelium, different cells, right? So that's microscopic anatomy. All right, so more microscopic anatomy here with chief cells and parietal cells and enteroendocrine cells. Here you're even seeing some chemical reactions happening. All right, so physiology. So physiology has to do with function, okay? Anatomy deals with structure, all right? So if you want to write something down, write this down. Anatomy, you can put dash structure. Physiology dash function, okay? So it deals with how the body and the different parts function, okay? Yeah, all right. So what's the relationship between anatomy and physiology? Well, big theme of the course is that structure determines function, okay? That's really important. So I'm going to give you a hint that that's really important, okay? So that is something you want to write down. Structure determines function. If you change the structure, you're going to change the function. And that's true at different levels of organization, which we'll cover later. All right. Speaking of levels of organization, at the smallest level, we're dealing with atoms, okay? As well as molecules, and that's at the chemical level of organization. All right, so next to where you put atoms, write / chemical level. Atoms will make up molecules. Molecules make cells. And collections of cells make up tissues. Collections of tissues make up organs, like your heart, your eye, kidney. Organs that are related make up organ systems. All the organ systems work together to create an organism. Okay. So here's an illustration of that. So again, the organismal level, human organisms are made up of different organ systems. Here's one organ system, cardiovascular system. It's the organ system level. Organ systems are made up of different organs that work together. So this is the organ level, okay? So this is a blood vessel. It's made up of different tissues like connective tissue, smooth muscle tissue, and epithelial tissue, which we'll learn about those later, all right? And these different tissues, so this is the tissue level. Here's an example of smooth muscle tissue, all right? One of those components of the blood vessel. And those are composed of different kinds of cells. Here's an individual smooth muscle cell. This is the cellular level. Cells are made up of molecules, which are actually just collections of atoms working together. Atoms and molecules are at the chemical level of organization, okay? So, you know, normally I would take a lot of breaks and stop and ask you questions, see how you're doing with this, and I will do that. It's just because we missed Monday, I kind of want to make sure that we get as much of chapter 1 covered as we can. Okay. That's all the individual steps. All right. So review the organ systems. Let's start with the integumentary system or integumentary system. It's your external body covering. It's your skin, it's your hair, and your nails. Protects the tissue that's deeper from injury. Regulates the temperature in your body. And you also have nerve receptors in your skin. So skin is your cutaneous membrane. So that's where the word cutaneous comes from. All right, so that's your integumentary system. All right. So there's your integumentary system. Okay, you can see that visually. It's the skin. You have oil and sweat glands there. Makes vitamin D. Okay, with contact from the sun. Okay, skeletal system consists of bones, cartilages, ligaments, and joints. Supports your system or body systems. Provides structural support. Attachment sites for muscles so you can move. You may or may not have known this, but it's actually where your blood cells are created. Okay, we call that hematopoiesis. It also stores minerals like calcium. Your visual, and if you didn't get all that, some of that's down here. And your cartilage, bones, joints. Okay, muscular system. So the skeletal muscles produce movement of the bones. And they do that by shortening or contracting. Those muscles contract or shorten. So all right, so the muscular system allows you to manipulate your environment. Obviously, locomotion's another word for movement. Also, you have facial expression because of so if you can smile or smirk or make different faces or frown because of the muscles in your face. All right, helps you with your posture, right? Helps you, even though you're not even thinking about it, the muscles in your core are supporting you so you have a certain kind of posture, however you sit normally, okay? And muscles produce heat, okay? When they move, they actually generate heat. Nervous system, okay? This system works very quickly. It's composed of your brain, your spinal cord, as well as nerves and sensory receptors. And it responds to changes both internal and external. So inside your body and outside your body. Nervous system works by sending messages to your central nervous system through what we call nerve impulses. And your central nervous system activates what we call effectors. These are muscles and glands. So the effectors do something, they cause an effect, right? So they send a signal to the muscle contracts or it relaxes. Gland secretes hormones, okay? All right, so you can see there, brain, you have sensory receptors in the eye, but you have various other spots in the body, spinal cord, nerves, okay? So you've got, again, responding to changes, activating muscles and glands. So we'll also cover the endocrine system, which includes the pituitary gland, the thyroid gland, as well as the parathyroid glands, the adrenal glands, the thymus, the pancreas, pineal glands, and the ovaries in females and testes in males. Okay. So the ovaries and the testes are parts of the reproductive system, but they're also parts of the endocrine system because they release hormones. Okay. Pancreas is part of the digestive system. It helps with digestion, but it secretes hormones, so it's part of the endocrine system too. Okay. All right, so endocrine system also secretes hormones that are involved in regulation. Regulates processes like metabolism, reproduction, and growth. Metabolism just deals with chemical reactions that happen in your body. All right, so this shows you locations for endocrine organs. So there's the pineal gland and the pituitary gland, thyroid and parathyroid glands, the thymus gland, adrenal glands, pancreas, testes in males, and for females, you would have the ovaries there. Okay, cardiovascular system. It's your heart and your blood vessels. What's your heart do? It pumps blood. What do the blood vessels do? They transport that blood that was pumped into them to the tissues. So the overall function of the cardiovascular system is transport materials in your body via the blood pumped by your heart. So what are some of these materials that get transported? Well, I'm glad you asked. Well, we have oxygen and carbon dioxide, different nutrients from what food you're eating, and waste products. Okay. All right. Here's the heart and the blood vessels. Okay. Lymphatic system. So it includes your lymphatic vessels, your lymph nodes, lymphoid organs, what does the lymphatic system do? Well, it returns fluids that have leaked out of your cardiovascular system or other systems back to your blood vessels. Okay. And it also serves to cleanse your blood, also has a role to play in immunity, fighting infection. So if anybody's ever noticed they had a swollen lymph node when they were sick, that's what that's about. All right, so this shows you location of some of the lymph nodes in the body. Also shows you thoracic duct, which is the lymphatic duct. Okay. Your lymphatic system tells you here disposes of debris in the lymphatic stream and houses white blood cells involved in immunity. So it's kind of what was said in the previous slide. All right, respiratory system. So it includes your nasal passages, your pharynx, the larynx, the trachea, the bronchi, and the lungs. Role of the respiratory system is to supply your blood with oxygen and to get rid of carbon dioxide. All right. All right, so here's image there, shows you with the nasal cavity, the pharynx, the larynx, trachea, bronchus, and the left lung are. Digestive system, so it includes the oral cavity, esophagus, stomach, small intestine and large intestines, and accessory organs. So digestive system is breaking down your food so your body can absorb the nutrients into the food or into your bloodstream. You can eliminate indigestible material as feces. So you can go to the restroom, get rid of the indigestible parts, parts you can't digest. right, so shows you locations for your oral cavity, esophagus, the stomach, small intestine, the large intestine, rectum, and the anus. Okay. Urinary system includes your kidneys, the ureters, urinary bladder, and urethra. Eliminates nitrogenous waste, maintains acid and base balance. And it regulates water and electrolytes. Okay. Okay. All right. So shows you the location of some of the urinary organs, like the kidney, the ureter, urinary bladder, and the urethra. Let's move on to the reproductive system. So for males, includes your testes, the scrotum, penis, the accessory glands, and the duct system. So the ducts are producing sperm, or sorry, the testes are producing sperm, and the duct system is carrying those sperm to the exterior. For females, reproductive system includes your ovaries, uterine tubes, uterus, and vagina. The ovaries are producing the eggs, and the uterus is providing a site for the fetus to develop. Okay. All right. So next slide just shows you some of the locations of the reproductive organs in men and women. Let's see. Okay. All right. Transitioning to new topic. Maintaining life. So the necessary life functions. So in order to maintain life, you have to be able to maintain boundaries between inside and outside, whether that's inside and outside of a cell or inside and outside of an organ, inside and outside of an organism. Have to be able to move in some way, whether it's inside or outside of the organism. Okay, you have to be able to move substances around. You have to be responsive. You got to be able to sense changes and react to them. You have to be able to digest, you have to be able to break down and absorb nutrients. And so for the sake of time, if you're writing, if you just kind of write the maintain boundaries, movement, responsiveness, and digestion. I don't have to keep moving. Okay. All right. Okay, metabolism and excretion. Okay. Metabolism is just chemical reactions that happen in your body. So here you're breaking down complex molecules, turn them into simpler ones, taking small molecules, making them smaller, making energy. And this whole process has some hormonal regulation. And again, the big terms are the ones that I really want you to know. So that's why I want you to focus on writing. Don't write all the details. Excretion has to do with getting rid of waste from those metabolic reactions. You can remove waste through your urine or in the feces. Okay? But metabolism and excretion. Okay? All right. Next functions are reproduction and growth. So write down reproduction and growth. So here reproduction could be talking about cellular reproduction or organism reproduction. And you're getting another generation through that process, whether it's another generation of cells or another generation of people. All right, or whatever organism we're talking about. Growth just means that the cells increase in size and number. Okay, that's growth. Okay? Increasing cell size or number. Okay. Now, in terms of survival needs, so this is separate from functions. What we just covered were functions. Now we're on to survival needs. So in order to survive, an organism is going to need nutrients and oxygen. So nutrients are the chemicals used for energy and cell building. Those include things like carbohydrates, proteins, lipids, vitamins, and minerals. Don't worry, we have a whole chapter on that, so don't, like I say, you don't have to write down all the details. Oxygen, you need oxygen for some chemical reactions, okay? Nutrients and oxygen. Okay, so what are your other survival needs? You need water, you need to have a stable body temperature, you need atmospheric pressure. So water is 60% to 80% of your overall weight. It's the most abundant chemical in your body. Provides for many of the metabolic reactions that happen in your body, in your cells. You need a stable body temperature, right? So 98 degrees. So if your body's not, if it's too hot or too cold, your body's not going to work properly, right? And atmospheric pressure, you have to have the right pressure so that you can have gas exchange, right? Because you need to be able to take in oxygen and get rid of carbon dioxide. So you have to have the right atmospheric pressure. Okay, digestive system. So this is just showing you just relation. You don't have to write anything down on this slide. It's just showing you how the systems work together. Okay, so the digestive system, bring in nutrients, break them down. Okay, eliminate, absorb matter. Nutrients get absorbed into the cardiovascular system and get distributed to the tissues. Respiratory system's taking in oxygen, eliminating carbon dioxide. Okay, and the oxygen is being picked up into the cardiovascular system, and the CO2 is being eliminated into the respiratory system to exhale it. Urinary system interacts with the cardiovascular system to eliminate waste. Okay, so they work together. Integumentary system is just protecting your body as a whole from the external environment. All right, so and I realize y'all couldn't see that, but that's basically what that shows you here. So again, interaction between the digestive system and the cardiovascular system, getting the nutrients, respiratory system, getting the carbon dioxide, releasing oxygen, urinary system, taking out the waste, okay? Okay, homeostasis. All right, so homeostasis just means maintaining your stable internal environment, okay? So two things I would write down, just that first sentence, and then what homeostatic imbalance is, okay? Since homeostasis is your equilibrium, okay? It's dynamic, which means you're in a constant state of motion in your body. Like things are always sort of changing, but the overall state needs to be equilibrium. It's necessary for normal body functioning and to sustain life. So in homeostatic imbalance just means you get a disturbance in your homeostasis, and that leads to some sort of disease. Okay. All right. So we're going to start here. So basically, we're just explaining a homeostatic control system. So you start out with the stimulus, okay? And the stimulus produces a change in some variable, okay? So then you end up with the receptor that's detecting that change. And so because of the stimulus, you're out of balance, right? And your receptor detects that. So then there's some input from the receptor through a pathway to a control center, okay, somewhere in your nervous system, okay? All right. So Then another pathway is used for the control center to send a message, some output, some information to an effector. Okay. And you'll use some response from that effector. And it's going to feed back to reduce the effect of the stimulus, return you back to balance, back to homeostatic level. Okay. So if there's a change, you detect it, have a response, go back to normal. Does that make sense? Okay. All right. So to maintain homeostasis, your body has to communicate through the nervous system and the endocrine system, through nerve impulses and hormones. Again, just as we mentioned, the receptors responding to some change in the environment, that's some stimulus, plural is stimuli, and that receptor again is sending information to a control center along an afferent pathway. All right. And your control center determines your set point or what's normal. It analyzes the information and determines the appropriate response. The effector then is the means to respond to that stimulus. Information's flowing from your control center to the effector along that efferent pathway. Okay. All right. So understanding that concept now helps you understand feedback mechanism. Okay. So negative feedback is what happens most of the time. And that's most of your homeostatic control mechanisms. So you're shutting off the original stimulus, whatever that stimulus was, or reducing the intensity of that stimulus. And this basically works like a thermostat in your house. So like if temperature, if you have it set at a certain temperature and it gets too warm, what happens? Air conditioner cuts on, right? Okay, what if it gets too cold? Then what happens? The heat cuts on, right? So you get back to your set point. Okay, so that's negative feedback. Okay. All right. So in a few cases, you'll see positive feedback. And it's going to increase your original stimulus and push the variable even further in the direction it was going. Does everybody see how that's different from negative feedback? So instead of taking it back, you're going to keep going further in that direction. Okay. The reaction starts happening even faster. So a couple of examples it gives you here. One is blood clotting. Okay, so when your body needs to form blood clots, once it starts, it actually, keeps going at a pretty fast rate. Okay. Now, for those of you, if you need to form a scab, that's great. But if you've got, some sort of illness, that can be really dangerous. Now, it also happens in mothers when they're having contractions and trying to get the baby out, right? That's also a positive feedback. The contractions get stronger and stronger, right? Okay. All right. And most of what's in the rest of this will be covered in lab but there's one slide I want to cover. Yeah, right here. So in lab, you'll learn about dividing the abdomen into, and the abdomen is basically like where your abs are, right? Your abdominal muscles, into four quadrants. You also can divide the abdomen into 9 regions. And so the middle region where the belly button is, it's your umbilical region, okay? And how this typically works, remember every side is based on the patient. So this is the patient's right side. This is the patient's left side. So patient's right side, patient's left side. Okay, opposite of what it would be for us, right? And so this works hypochondriac, lumbar, iliac, and inguinal. Okay, and lumbar is the lower back region. And it's lumbar. Iliac and inguinal has to do with the hip. Okay. So and then you've got epigastric and hypogastric. Gastric basically means stomach. So epi is above the stomach, hypo is low. So it's low, it's below the stomach. Okay. And in the middle you've got the umbilical region. All right. So I want you to be able to know those regions. Okay. So you want to take a picture of it, you can take a picture of it. You want to write it down, you can. It's up to you. But want to make sure you've seen that. Okay. So what I want you to do at this point is go on to your Canvas student app, go to the discussions, and there should be an exit ticket. Week 1, day 1. Why don't you go ahead and do that?